Today we're going to take a look at how we can automatically generate our weapons based on the component data in our weapons data list. So what we're going to do is make it so that when we run the game, over here on our primary and secondary weapons, instead of having these components already attached to this game object, it'll look something like this. So we run the game, and the components just get added for us based on that component data list. To do this, we're going to create a separate script called the WeaponGenerator script that is responsible for looking at all of these components over here, and then adding the associated weapon component to the weapon game object. So welcome to Ardent, my name is Heinrich, and let's get into it. Okay, so the first thing we need to do is, how do we know what weapon component matches with what component data class over here? As in, if we only had access to our weapon data, how can we know which one to add? Then this is something that's quite simple to do. What we're going to do is, for each one of our component data classes, we're going to assign a component dependency. So let's go ahead and open up our scripts. And the first thing I want to do is I want to come down to my weapons folder, and then in the component data folder, let's go ahead and open up the component data class. Now in here, in the base component data class, let's just go ahead and declare a public variable that has the type, and we'll just call it component dependency, and then give it a public getter and a protected setter. So this is the variable that we're going to look at when we're trying to figure out which weapon component matches with this specific piece of data. So what we need to do now is, in every single component data that we've created so far, so our action hitbox data, damage data, movement data, we need to go ahead and set this to something. So let's start with the action hitbox data. Come in here. And then what we're going to do is create a constructor for this data. So we can just say public action hitbox data with some brackets. And then in here, all we do is access our component dependency, and we set this equal to type of action hitbox. So notice this is action hitbox, not hitbox data, and we're calling type of to get the type object from the action hitbox class. And that's all we need to do. Now it's easy for us to know that this is the weapon component we're looking for when we're dealing with this data class. So next, let's go ahead and do the same thing for the other classes that we've made so far. So next up is damage data. So now instead of rewriting the constructor with writer, I can say alt insert and generate a constructor. You can do the same thing with Visual Studio Code. I'm just not sure what the shortcut is for that. And then in here, again, we just say component dependency equals type of damage. Next, we can come to movement data. In here, the same thing, go ahead and create a constructor. And then inside the constructor, we say component dependency equals type of movement. And then last up, we have our weapon sprite data class. So the same thing once again, generate a constructor. And then in here, say component dependency equals type of weapon sprite. Cool, so now all of our weapon component data classes know the weapon component that they're associated with, and any new ones we create, we just need to remember to create a constructor and set the dependency. Next, we can go ahead and get started on the weapon generator class. So let's come just to our weapons folder, go ahead and add a new mono behavior in here, and let's just call it weapon generator. But like I mentioned, this class is going to be responsible for all the logic of adding and removing weapon components from our weapon game object. This is the class that other things are going to interact with when they want to change the weapon. So for example, when we equip a new weapon, our inventory class is going to interact with the weapon generator to tell it, here is the data for the new weapon, do your thing. So the first thing we need in this class is a reference to our weapon itself. So I'm going to create a serialized field, private weapon, and this time I'm using serialized field instead of setting our weapon reference in awake, just because I feel like I haven't been using the inspector enough. The weapon generator class is always going to be with our weapon class, so we might as well just drag it in there in our prefab, and it's set up. We don't have to worry about this ever causing any sequencing issues. But if you want to stick with getting this reference in awake, you're more than welcome to. Next, we're going to go ahead and create the function that we're going to call when we want to generate our weapon. So we'll just say public void generate weapon, and this function is going to have an input parameter of type weapon data so that we'll just call data. So again, anything else that wants to change our weapon is going to pass the new weapon data to this function. So we actually want to go ahead and come to our weapon class, And instead of exposing the weapon data over here, let's go ahead and remove field, serialized field there, and just move the variable down. What we want to do instead is set this variable from our WeaponGenerator class. So let's go ahead and create a function to set the data, and we'll just do that underneath the setCore function. You can say public void set data, and this is going to take in a weapon data SO called data, and then here we'll just say data equals data, like that. That means we can come back to our WeaponGenerator class, and the first thing we want to do in the GenerateWeapon function is say weapon.setData, and the data we want to set is just our data. Okay, so let's quickly talk about how this GenerateWeapon function works. So what's going to happen is we can call this multiple times throughout the lifetime of our game. Whenever we pick up a new weapon, we're going to generate weapon. So that means we're going to take the current weapon game object as it is, and we're going to remove all of the old dependencies that we no longer need and add new dependencies in there. But just to make things a little bit more efficient, we're going to only add the ones that aren't already there and just remove the ones that we know we no longer need. So to do this, we'll start off by getting a list of all the weapon components that are currently on the weapon, and then as we loop through our list of dependencies that we know we need, we're going to check if that weapon component already exists in that list. If it does, that means we don't need to add it to the game object again, and we can simply move on. While we do this, we're going to keep track of the components that we've added, so basically just create a second list of dependencies, but this time referencing the actual components instead of the dependency types. And then at the end, we can compare the list of items that were on the weapon to begin with to the list of items that we added, and just remove the difference, the ones that were on the weapon before that are no longer needed. Hopefully that made sense. If not, as we step through the logic, it should. So that means the first thing we need to do is create 3 lists. The first one, private list, is going to have the type weapon component. In this list, we're going to store all the weapon components that are already on our weapon game object. So we can say components already on weapon and set this equal to a new list. Next, I want another private list that is also weapon component type. And this one is going to store all the components that we've added to our weapon. So we'll say components added to weapon. And of course, initialize it to a new list. Finally, we need our list of dependencies. So let's create a private list. And this time, instead of weapon component, it's going to be of type type. And it's red because we need to include the correct using statement. So let's do that. It is using system.type. And this one I'm just going to call component dependencies. So next, just to make sure we have a clean slate, let's go ahead and reset all of these or clear them at the start of the GenerateWeapon function. So we can say components already on weapon dot clear, components added to weapon dot clear, and then finally component dependencies dot clear. Next, let's go ahead and get all the components that are already on our weapon. We can do this by saying components already on weapon is equal to get components. And notice it's components with an S, and the type we're looking for is weapon component. So this is going to return an array of weapon components. So we can just say dot to list to turn it into a list. Next, we want to get our list of component dependencies so that we can start looping through them. But to do this, we need to go ahead and come to our weapon data scriptable object class, which is over here. And over here, we can quickly create a function to just loop through every single piece of data in ComponentData and get that dependency. So let's just create a public function that is going to have a return type of list, and the type of the list is type. And let's just call it get all dependencies. Like that. And then don't forget to include using system.type. Now in here, we can write a single line link statement to look at every single item in our component data list and get that specific variable from it and create a new list of all those things. So to do this, we just say return component data, which is the list that we're looking at, dot select, meaning we're going to look at every single item in component data and take something from it and construct a new list with it, or in this case, a new IEnumerable. And in here, we just need to simply say, what do we want to select? So we can say component, which refers to each individual component that we're considering. and we want component.componentDependency. So that has constructed an IEnumerable for us that contains every single component dependency that is present in our component data list. And then now we just need to make sure that we return it as a list. So again, we just say .toList. So that means back in our WeaponGenerator class, after we get all the components that are already on the weapon, we can go ahead and say component dependencies equals data.get all dependencies. And so with that, we're ready to start looping through it and adding our components. So let's create a for each loop. And we'll say var dependency in our component dependencies. So for every single dependency in this list, we're going to do something. So the first thing we want to do is check if we've already added this dependency to this weapon. Now, because we can only ever add one of a certain data type to our list, this shouldn't ever happen, but it's better to be safe than sorry. So what we're going to do is check if a component exists in this components added to weapon list that has the same type as our dependency. And if so, we just want to go to the next iteration of the for each loop. So we just say if components added to weapon dot first or default, and for every component, we're going to check to see if component dot get type equals dependency. And if so, we're simply going to say continue. So again, this is just another link statement that is saying we're considering every single item in this components added to weapon list, and for every component we're checking to see if the component's type is the same as our dependency. So the first time that this is equal to true, it's going to return that item from this list. And if so, if will evaluate to true, meaning there is an item in this list that we care about. And in that case, we know that we've added this component to this weapon already, so we can just continue to the next iteration of the for each loop. So if this does not return true, and we continue to the next line of code, we want to check to see if this component already exists on the weapon itself. So we haven't added it based on our dependencies yet, but it is already on the weapon. And to do this, all we say is var weapon component. So just creating a variable, set that equal to components already on weapon, and now it's basically this exact same line of code. So let's just copy that and paste it in here. So we're performing the exact same check as we did in this if statement. So we're checking to see if an item exists in the list that has the same type as the dependency, but this time instead of just having an if statement, we're storing the result in a variable. So what that means is this variable is either going to point to a specific object, or it's going to be equal to null if this doesn't find anything. So if it doesn't find anything, that means that our weapon does not have this weapon component attached to it yet. And so we need to actually add this component. So what we'll say is if weapon component equals null, so again, meaning the component does not exist on our weapon game object, then we want to add it. So we can say GameObject.add component, and the component we want to add has the type dependency. Now we want to make sure we track that we've added this dependency to our weapon game object. So we need to add it to our list called components added to weapon. So what we want to do is actually keep track of this as well. So when we add the component, we want to save a reference to it. And we'll just store it in our weapon component variable that we created up there. So we can say weapon component equals GameObject.addComponentDependency. But now this gives us an error because add component returns just a object that has the type component, and weapon component, because of the line over here, has the type weapon component. But we know that this is a weapon component because our dependency is a weapon component, so we can just cast it as a weapon component. And that means now after this if statement, we're free to go ahead and say components added to weapon dot add our weapon component. And so now notice that if weapon component was not null, so meaning this line actually did return something, we're still saving it in this list. So at the end of our for each loop, the list of components added to weapon should match our list of dependencies perfectly. And that's everything for inside of the for each loop. So at the end of it, all of the components should be added. And that means next we need to go ahead and remove the ones that we no longer want there. To do this, outside of our for each loop, we can say var components to remove. So this is going to hold all the components that we want to get rid of, and we'll set this equal to components already on weapon dot accept components added to weapon. And so what this is going to do is it'll look at every item in components already on weapon, and it'll remove any item that also appears in components added to weapon. So at the end, we'll be left with just a list of all the components that are on the weapon that weren't added by our dependencies, meaning those are the ones we want to remove. So that means finally we can just go ahead and loop through this list and destroy each of those components. So I'm just going to use a writer shortcut to create our .forEach loop. So for each weapon component in components to remove, we can just go ahead and say destroy weapon component. And that is essentially our GenerateWeapon function. So now eventually we're going to call GenerateWeapon from our inventory system or whatever to indicate which weapon to generate. But for now, let's just go ahead and call this in start. So let's go ahead and create the start function. And in here, we can just say GenerateWeapon. And then now we need some data to pass in. So for now, let's just go ahead and create another serialized field, private weapon data SO called data. And then let's just pass it in here to our GenerateWeapon function. And so now that is almost everything we need to do to test this out. Now, unfortunately, this is leaving us with some sequencing issues. And let's consider what is happening. So if we consider specifically one of our weapon components, in this case, our damage component, go ahead and open that up. We can see over here in the onEnable function, we're making use of the hitbox variable, which is just a reference to our action hitbox weapon component. So our damage weapon component is using another weapon component. And we set the reference to this weapon component over here in the awake function. Now what happens is when we add this component to the GameObject with this code over here, so add component, it immediately calls the awake function and then the onEnable function. So that means if our damage weapon component is added to our weapon GameObject before our hitbox weapon component, then that reference to the hitbox component is never set. So this is going to cause some issues for us. So we're going to have to move some of these things to the start function instead. Okay, so let's go ahead and consider our weapon component class for a second. So in here, our current pattern that we were using is we subscribe to events in onEnable and unsubscribe in onDisable. Now, because our onEnable function is called directly after the awake function, we run into the same issues. If we're trying to subscribe to any events that come from a different weapon component, that's not going to happen because we can't actually get a reference to that component until the start function. So instead of subscribing to events in the onEnable function and unsubscribing in onDisable, we're going to subscribe to events in the enter function and unsubscribe in the onDestroy function. And that'll make sure we're still clean. We're still unsubscribing from events whenever we no longer plan on having this script around. Go ahead. And over here, we already have a protected virtual void start. So all we need to do is let's just go ahead and move these two lines from onEnable to our start function, like that. And so for now, just to make sure that we're fixing it everywhere, I'm going to completely get rid of the virtual void function so that we get some errors where we are making use of it. Now for our onDisable, instead of moving things around, I'm actually just going to rename this by hitting F2 and say onDestroy. Let's go ahead and take a look at some of our other classes. Let's just start at the top with our errors, action hitbox. Now in here, we're trying to override the onEnable, but instead we're going to move this up to start, like that, and get rid of the onEnable completely. And over here, we can see that it also renamed onDisable for us to onDestroy. So next we have our damage class. So open that up. Over here, we are making use of awake. Let's just go ahead and change that to start, like that, and then move the line where we subscribe to the onDetectCollider2b up over here, and then get rid of onDisable or onEnable completely. That should be everything here. Next one is our movement class. So in here, we're not making use of the start function yet. So instead of getting rid of onEnable, let's just go ahead and alt-click like that and rename this to start. So notice in that case, I didn't F2 to rename, I just renamed it manually because I only want to change it here. I actually don't think it would have renamed it anywhere else anyway. Okay, next we have our weapon sprite class. So over here, we're doing quite a bit of stuff in our awake function. I'll take a look at that in just a second. In our onEnable function, we are registering to our sprite change callback function on our sprite renderer and also subscribing to the onEnter function. So this one we actually don't need anymore because we added that to our weapon component over here. We created a handleEnter and handleExit function that we can override. So back in weapon sprite, let's just go ahead and get rid of this completely. And same thing in the onDestroy. And let's take a look at our handleEnter function. So protected override void handleEnter. So this should still get called. Next, our awake function in here. So in the awake function, we're getting a reference to our base sprite renderer and our weapon sprite renderer. And you can see over here, I left myself a note that I need to fix something when I create the weapon data. And so what was happening here is I'm trying to access the base game object from the weapon itself instead of finding the base game object. And now that we're adding this component to our weapon later in the game, that means that we can do this instead. So let's go ahead and uncomment this and get rid of our comment. And then we can also get rid of these two lines over here. Let's just keep everything similar to how it was. So not much has changed. It's just now instead of calling find object again, which is an expensive method, we're just getting it from the weapon itself. But now we still need to make sure that this is start instead of awake. So just go ahead and change that to start. And then we can move up base sprite renderer.register sprite change callback up over here. And then get rid of the onEnable completely. So that does it for all of our errors. I hope I didn't miss anything. So I think we're ready to go ahead and test this out. So let's go back to Unity. And the first thing I want to do is clean up our weapon game objects. So let's just click on primary weapon, actually click on both primary and secondary weapon. And let's just remove all of these weapon components that we've added up till now. So the only script we want on here is our weapon script itself. Now, if we select just our primary weapon, you'll see that our weapon sprite weapon component is over here with a little minus and it's kind of grayed out. That means it's part of our prefab, but we've removed it in this instance of the prefab. We can go ahead and right-click on this, say remove component applied to prefab. So that means that our prefab now also no longer has that script. So if we click on secondary weapon, you'll see it's been removed over here as well. Okay, so back on the primary weapon, let's go ahead and add component. I want the weapon generator class, and then I'm just going to drag in a reference to my weapon script. Then I'm going to right-click on weapon generator and say added component applied to prefab. So now both our primary weapon and our secondary weapon has this class with the reference set up. Now in my secondary weapon, I'm again going to drag in sword 2 as the weapon data, and in primary weapon, just sword 1. So with that done, I believe if we run the game now, we should see our components generate over here. Let's see if that happens. Boom, there we go. So we have our weapon sprite, movement, action hitbox, and damage. Same thing goes for our secondary weapon. And if we attack, you can see everything still works. Our dummy takes damage. So primary attack is still sword 1, secondary attack is sword 2, except a little bit of an issue. What's happening there? Oh, what's happening there is I changed number of attacks to 3 in a previous episode where we were messing around with auto-filling some stuff here. But our weapon sprites doesn't have anything for attack 3. So let's just change this back to 2 for now. And now if we run the game, that was just me messing around. Everything still works. And so now theoretically, if we were to change this data and call that GenerateWeapon function, our weapon should change. So let's go ahead and try that out. Back in our editor, let's go ahead and open up our WeaponGenerator class. And in here, I'm just going to create a temporary function underneath start, private void test generation. And in here, I'm also just going to say generate weapon with the data. Then above it, we can add the context menu attribute. And I'm just going to say test generate. So now back in Unity, let's go ahead and run the game. If we attack, everything still works. So we've attacked 3 times with our secondary weapon now, meaning we'll be on the second attack. Let's go ahead and click on our secondary weapon. And let's add our sword 1 data over here. Right-click on Weapon Generator and say Test Generate. So both these weapons share all the same components and nothing will change here, but it should have also updated our data. Let's see. It did not. And now we're getting some issues. Okay, so what did we not consider? So at least our weapon generation works at the start. But because we are not resetting components that were already there by removing them and adding them back on, they might still have some state left over from before. And I actually think I know what the problem is. Let's take a look at our scripts. So if we take a look at weapon component itself, in the generic version, over here, we are setting our data variable equal to weapon.data.getData in the awake function, meaning this is only ever going to happen the first time we create this component. But we need it to happen whenever we regenerate this component as well. So let's go ahead and fix that. Let's come up to our weapon component class, the base weapon component class, and let's go ahead and create a new function called public virtual void. And this function is going to be called init. Now in the base weapon component class, it's not going to do anything. But if we scroll down to our weapon component generic class, instead of awake over here, let's change this to our init class or function. And then this needs to change from protected to public. So that means all we need to do now is come back to our weapon generator class. And in the generate weapon function, we need to call init somewhere. Now, where is a good place to do that? I think over here, before we add it to the components added to weapon list. So here we can say weapon component dot init. And so all that means is we just need to make sure that we've set the new data, which we do in the very first line, before we call this, and everything should be fine. So let's try that out again. Let's come back to Unity. Let's run the game. And let's see if there's any other surprises waiting for us. So if I call my secondary attack, and then click on my secondary game object, change the data to sword 1 from sword 2, right-click, test generate, and now attack. That's my secondary attack. It's working. So now both my primary and secondary attacks use my sword 1 data. So there we go. Now we have a way of generating our weapons at runtime instead of having to come and add our components every time we create a new component to test it. And I think that is going to be a good place to end for this video. So at this moment, I'm not 100% sure what the next video is going to be on. Once I know, I might go ahead and leave a comment down below. I just need to go and look at my prototype again and see what makes sense logically to do next. And speaking of the prototype, if you would like early access to the prototype that I'm using to build this series, it is available to all of the tiers over on my Patreon. And so with that being mentioned, I would just like to say thank you to all of my supporters and wonderful people over on Patreon. And a huge special thank you to Cody Lee, SM, Madger Sins, Jake Skarupa, Patrick, Atami, Mike Rodriguez, Nathan Ackley, and 12 Feet Up. You guys are absolute mad lads, and I hope you all have a wonderful day.